practice for lesson 4. I'm going to do numbers 2, 4, and 5. So it says, number 2, a population of 50 fruit flies is increasing by 8% every day. So we start by writing the model, exponential model. Y equals. Now remember, our starting value is 50. That's the first number you write. When I do percent increase, I'm adding that percent to 1. So I'm going to do 1 plus 0.08, or you could write this as 1.08 to the x power. Now the question is, how long until the number of flies triples? So then we'll solve the question. So if I start with 50, the triple times 3 of 50 is 150. So how long until this amount of fruit flies gets me to 150? So I'm going to solve this exponential just like we were doing in our notes. We'll start by dividing by 50. So I get 3 equals 1.08 to the x. And then from here, all I have to do is take the log of both sides. Log of 3. Our logarithm law says that that x is going to come down in front of the logarithm. And then I'm going to divide both sides by log of 1.08. Right, so I go ahead and type that into the calculator. Log of 3 divided by log of 1.08. And I get 14.275. That's the number of days. So then it's going to take 14.275 days until there are 150 fruit flies. Let's get to number 4. There's a lot of information in this paragraph here. Let's focus on what's important. This is talking about a black-footed ferret. Okay? Now, it looks like, let's see. Start with the second row here. As of 2013, there were 1,200 black-footed ferrets in the wild. Since 2015, the population has been going up by 3% every year. That's why I needed to start with the 2013. Now, if I'm writing a model, we'll have y equals 2,000, or not 2,000. The number of black-footed ferrets you started with was 1,200. And it's increasing by 3%, so that's that 1 plus 0.03. I'm making a mess of this one. 1 plus 0.03. Now we want to know, after how many years will this population be equal to 1,500? So instead of y equals, I want to put 1,500 there. I want to know, when are there 1,500 black-footed ferrets in the wild? So I'm going to solve this. I'm going to divide by 1,200. And let's see if 1,500 divided by 1,200 gives me a decent number. It does, 1.25. So I'm going to rewrite that as 1.25. So I have 1.25 equals 1.03 to the x. And then from here, all I have to do is take the log of both sides. Equals x times the log of 1.03. Remember, I can move that x in front by our logarithm law. And then divide by log of 1.03. It's going to get x by itself. And I'll get to know how many years until I have 1,500 black-footed ferrets. So let's take the log of 1.25 divided by the log of 3. And it says it's going to take that doesn't seem right. Oh, 1.03. That's why I typed it wrong. 7.549 years. So in a little over 7.5 years, the population of ferrets would go up from 1,200 to 1,500. All right, number 5. The students interested in joining knitting club at Hayes is going crazy. Initially, there were 3 students interested in the club, and the number of people wanting to join knitting club, which is a real club, by the way, it's for house clubs, doubles every day. So if I wrote my equation, I would say there were 3 people initially. It's doubling every day. Now we want to know how long until the entire school of Hayes days wants to join knitting club, which is 1,700 people. So instead of Y here, I'm going to put 1,700. I want to know how long, how many days until there are 1,700 people in this club. So I start by dividing by 3. 1,700 divided by 3, I'm pretty sure is not a nice number, but let's see. Nope, it's not. So let's just leave it at 1,700 over 3 equals 2 to the x. Now from here, you would just solve for your log like normal. Log of 1,700 divided by 3 equals x times the log of 2. If I divide by the log of 2, I'll get the number of days. So we'll type this in. Log of 1,700 divided by 3 divided by log of 2. Looks like it's going to take 9.146 days until the whole school wants to be in knitting club. All right, you are ready for your test review. Try the other problems here. If you're good at solving exponentials, then you'll be good at solving the modeling problem.